Okay, welcome everyone. Just going to wait as people join the room.
Some familiar faces there.
Great. So welcome everyone. Maybe just it's always nice. I know we did this last week, but Michael's not met any of you, and there's some new faces. Maybe just pop in the chat where you're joining from. It's kind of just fun to get a sense of the really truly international nature of the audience. And then if you feel like it, Michael and Bernardo, you can glance at that. And I'll just say a couple of things as we warm up. So just to say, very often I'll try and slow Bernardo down a little bit if lots of terms come up that aren't familiar to that may not be familiar to everyone. But this week I feel very privileged to have Michael Levin here, but for a limited time, it's an hour and a half, and so I'm tempted to both let you dive in as deep as you want to, and then we've got Bernardo for future weeks, and if there's terms that we need to go back over and unpack, we can do that in the future weeks that we have Bernardo with us. So I'm going to take a cue from a podcast that Michael was on recently, and Bernardo, you've been on several times, Theory of Everything. And you mentioned, Michael, when you were there, that you really loved a question that he opened with and said, oh, everything should open with this question, which is just to invite you both to briefly say something that you admire or respect in each other's work.
Should I start?
Sure.
I'll set the context first. I think one of the most critical problems we face in science today is the problem of morphogenesis, because, DNA, we understand how it produces proteins, but producing proteins is like a brick factory. We know how the bricks are made, but how are they put together in the right places? So instead of a heap of bricks, you have Cologne's cathedral. So that's the problem of morphogenesis. How do you go from a protein factory to a fully structured human being? And Michael's work in this area, I think, is not only offering a very plausible avenue for making sense of this from a scientific perspective. It is forcing open some philosophical doors that we will have to pick through in order to have a more coherent understanding of nature. So I think it's seminal work, critical.
Well, thank you so much. I love a lot of the things that Bernardo has done. In particular, I think that you've taken on basically the biggest questions in science and philosophy, and I love that your books, especially The Idea of the World, is one very rigorous, but also very understandable. Among many others who have written things like this, it's just the clarity of thought and of the writing I found very impressive. I also you have a computer science background, as I do somewhat, and I follow the Byte. I love the hardware stuff, and I love that stuff. That's a lot of where my approach to things have come from, is messing around with things like this when I was younger. So
thank you, sir.
Yeah, I'd noticed that you both had that in common in sense of having two disciplines, or at the very least two disciplines that you straddle and draw from. So yeah, I'm gonna open with a question that I feel draws on lots of the questions people have been submitting and asking, and also talk a little bit more than I normally talk, in doing my best to summarize some context of the conversations you've already had, which will hopefully allow us just to continue the conversation rather than going back over it. But to summarize the question, and it's made to you, Michael, and then we'll bring in Bernardo to either ask you questions or dialogue between you, and then we'll see where it goes from there, which is what reason might there be to believe that certain configurations of, from one perspective, basically physics and chemistry, have an inner life, and what physical markers might give us a clue that, for example, cells might have agency and boundaries, but thermostats don't. So I'll just give a little bit of context to that, which is, some people have said that it's useful just to hear someone put these concepts in slightly different words, and it'll also give you both a chance to correct me if my understanding is totally off. Michael, in a previous recent talk, you said that basically fundamental to your work is to understand scaling of minds and how that border between a given self and the outside world is formed. So my understanding of Bernardo's position is that we're starting from the notion of reality as one unified field of consciousness. There's mental processes that are arising within that, some of which dissociate, much like whirlpools might dissociate in water. And then when the mental processes in the surrounding water, to use the metaphor, impinge on the activity of that whirlpool, that's what we might call perception. You'll have an opportunity to correct me, Bernardo, if I'm making a mess of your your presentation. And then equally, when one whirlpool affects the activity of a neighboring whirlpool, that would be the perception of an alter or a self or another entity. And so the question is, when we look in our perception of the world, of like, well, how do we know that one thing might have its own boundary, distinctive perception or point of view, versus something like a rock or a waterfall or a computer that you, if I've understood you, suspect doesn't have its own individualist point of view. And you've looked for metabolism, an organism with metabolism as a sign of a dissociative boundary, to use your terms. And then conversely, Michael, if I've understood you, you've looked at like how an organism is made of many different parts, trillions of cells, and then you've done all these amazing experiments that indicate that cells appear to have autonomous goals, and they also make up larger entities such as a kidney or a liver that is also a nested, semi-autonomous, or has goals that are separate from the goals of the individual cells and also separate from what I might be perceiving as my goals. And then equally, all those organs build up to make me or you or higher order agents that go about our business. And that you've considered or found that one of the principal mechanisms for coordinating a group of cells to cooperate and behave as a unified self with a common boundary is the bioelectrical field that cells cooperate to produce. So I'm just noticing we've kind of got metabolism as one potential thing to look at, and then bioelectrical fields that are cooperating in one way or another. And just so everyone's up to date, in case not everyone's seen the video. So in the last conversation, Michael did say that you said that if you had to guess, it's probably not that we're gluing separate consciousness together in a kind of panpsychic way, but that it's most probably reassociating mental processes or reassociating, mental processes in what is already an underlying unified field. And I noticed also elsewhere you talked about, at least since the 40s, there's a non-magic way of understanding how machines might have goals that they can pursue in various degrees of intelligence. So I'm kind of wondering, am I understanding correct if you'd consider a thermostat not to have its own consciousness or inner life, whereas if I've understood you correctly, a cell probably does? And then just to reiterate, go all the way back to the beginning, just to summarize the question, like what are these physical markers or what might be the clues of something having an inner life or not? And what would we look for in terms of finding what boundary we probably believe that it might have? Okay, so I'll just make sure, so it's directed at Michael, but I'll just check in with Bernardo that I haven't made a total mess of your, okay.
All good.
Right.
Well, thank you for that summary. That's really good. A couple of things, and I preface this by saying that unlike Bernardo, who's had several books devoted to this topic, I haven't said much publicly on consciousness. Right? That's not what I've mostly been working on. So I'm not going to pretend that I'm going to trot out some brand new theory of consciousness here, but I will say some things about it. So I've been focused on a different angle of it, and it's funny because I often discuss this question with people, but it's usually a very different audience that's coming at it from a completely different perspective. So my the way I slide into what I'm about to say is a little different than maybe than I would use here, because I'm fundamentally on board with everything that with your summary of Bernardo's idea. I'm completely on board with that. But I want to say three things to kind of show all of this from a slightly different angle. The first thing is that we often there's a common conversation that I have with my colleagues where people say, well, this is a cell, or it's an organ, or it's maybe some kind of hybrid thing that's partially biological, partially engineered. Maybe it's an entirely engineered thing, and they'll say, well, there's no way this thing has any kind of inner life. And it's posited as kind of a philosophical commitment, as you know, and so then we can ask, and I've had these discussions with people at neuroscience conferences, but you've got an inner life, and not everybody, but most people will say yes. And then you say, well, what's the substrate that underlies it? And they will say it's the brain, of course, it's neurons. And then we can say, what is a neuron? And so somebody will, let's say, write down 4 or 5 properties that neurons have. And at that point, I will say, yeah, but every cell in your body has that. They all do it. And the time scale is different, but actually, it's actually very non-trivial to say what it is that neural networks do that other cells in your body do not do. And so at one point, we're not done yet, but we started a kind of project where you can make a table where you just show the major theories of consciousness and what it is about the brain that they think is sort of the magic component here that allows them to do this. And we can just look at all of the criteria that each of these theories has and ask, what do these things appear everywhere else? And in fact, certainly in all the way from single cells, we can talk about what happens before cells, but certainly from single cells, they do. And so, now basically I'm not sure about much about consciousness, but the one thing I'm pretty sure of is that for whatever reason, people think that brains are associated with it. You have to be open to that exact same thing elsewhere in the body for exactly the same reasons. And then oftentimes people will say, but I don't feel like my liver is conscious. Well, of course you don't. You also don't feel like I'm conscious, right? It's nice for me to talk to your left hemisphere, right? For our 2 left hemispheres to talk to each other, but we actually don't. We don't have primary first-person perspective on anybody else, and certainly not on any of our organs. So we have to be open for mechanistic reasons. We have to be open to that. The second thing I'll say is that what I consider to be so I've been working on a framework which I call TAME, TAME, technological approach to mind everywhere, and the idea is that what we need is a rubric for understanding the different types of minds in very unconventional embodiments. It is completely implausible to me that in the whole universe, the only kind of minds that exist are ones that show up in this kind of architecture. That seems implausible to me. And so we need to be able to, not just birds and primates and maybe an octopus and a whale and things like that, but we need to really be able to think simultaneously about hybrids and hybrids, these mixtures of biological and engineered kinds of constructs and synthetic beings that we might make, and things that existed at the very beginning of evolution and things that might be exobiological agents, AIs. We need to be able to think of all of it. And when I think about what all of these things have in common, what I came down to is this notion of a cognitive light cone, this idea that what's important about agents is that they have goals, that they have some degree of competency of pursuing these goals in some kind of space. That space doesn't have to be 3-dimensional space. We're good at recognizing agents in 3-dimensional space, but there's the space of gene expression, the space of anatomical configurations, the so-called anatomical morphous space, the space of physiological agents, and these other spaces are places where other beings strive and suffer and live and die, and we're not good at recognizing those. We are made of many overlapping versions of these agents, and we have to. I think we have to recognize that when any kind of a claim about what the space is that something works in, what the goals are, and what competencies they have to work in those goals, those are all from some observer's perspective. We as scientists, but also parasites, potential mates, your body parts, things that you are part of. All these things can also be observers that have models of what's going on to better control or relate to you, and it's not just the scientists. And therefore, we have to be humble about the fact that when we make assignments of these kinds of things about cognitive level, about inner perspective, and so on, we are basically taking a kind of IQ test ourselves, right? These are all observer relative things that we have, no guarantee that we've caught everything that there is at any point. In fact, I think we're pretty bad in general at guessing this. And so the last thing I'll say that addresses kind of the thermostat issue and so on. I see all this as a continuum. I don't like scenarios where we say, yes, this definitely is, and this definitely isn't, because it leads to all kinds of pseudo problems, because inevitably we can make chimeras and all kinds of continuous. We can fill pretty much any 2 points on the continuum. So here's how I like to think about it in terms of what the continuum is. To me, one of the critical things about the continuum is how seriously do you have to take that system's inner perspective in order to optimally relate to it? So if you've got a bowling ball on a kind of a landscape with various bumps and valleys, your view of that landscape is good enough, right? If you understand the landscape, that's it. You can do pretty well. You know what's going to happen. If you have a mouse on that landscape, your view of that landscape is not nearly as important as the mouse's view of that landscape in terms of predicting what the mouse is going to do. He may have been rewarded and punished at different places on there. He may have different valence about where he's going to go and so on. So your view is not nearly as telling as to what's going to happen, and more importantly, how to manipulate what happens, which we want to do in let's say regenerative medicine and things like that. So and then of course you have everything in between. You have self-driving vehicles, and you have and even when you get down to the lowest level of physics, you have things like potential energy, right? Which is really interesting. It's like this really basal version of a property that reflects a system's potential, its history, and so on. So I think to the extent that you need to take seriously what that agent thinks about the outside world, what is the self model, how much history is there, how much memory is there, and so on, that's the extent to which you need to take seriously their inner perspective. And it might be very simple and very low, and it might be slightly higher, and it might be very high. So that's my long-winded answer.
And can I just clarify one thing before Bernardo comes in? But that whole premise could be done without having to worry about if something has an inner life or not. Like there's something that it's like to be an AI or a thermostat, or are you assuming that if there's an agent and it has a goal and it?
Well, I think that if the criterion here is to actually have good prediction of what and control over what's going to happen, right? So a really efficacious relationship with some system. For a large, I think the number of cases where you can really do without considering an inner perspective is vanishingly small. I think for most systems that we're interested in, if you really wanted to be good at interacting with it, you are going to have to take very seriously what is that agent's perspective, and I think that creeps up very early on the complexity scale. You don't have to wait till you're confronted with humans and try to think about what their long-term motives are. By the time you have gene regulatory networks, gene regulatory networks learn from experience. They have 6 different kinds of memories they can do, and if you want to interact with something as simple as a chemical pathway in a way that not just philosophically, but actually to say, okay, I'm going to make this thing act in a different way because I have some disease state that I want to cure or whatever, you are really going to have to take very seriously that this thing has memories, it has an experience of the previous world, it has regions in its state space that it prefers and ones it doesn't, and then the rest of it is just about what tools are you going to use. Are you going to use the tools of psychoanalysis? Are you going to use the tools of behavior shaping? Are you going to use the tools of cybernetics or hardware rewiring? There's whole kind of spectrum. But I think there are the vast majority of interesting systems. You cannot get away from this notion of taking the inner perspective seriously.
Are you speaking only of biological systems, or you're speaking more generally?
I'm speaking more generally, although it's most of our experience, of course, to date is with biological systems. So it's hard for us to know what kind, we have an N of 1 really, like in all of biology so far, the things that we've gotten somewhat good at developing, the tools of behavioral science. Let's say it's just an N of 1 type of life stream that we've had on Earth. So we're not really good at it at all about other things. But no, I'm not. I don't think there's anything magical in the substrate. I think protoplasm and such, it's nice, but I don't think that's where the magic is at all. So I fully expect these things to be realizable in other media.
I'll just make a couple of comments briefly. There's a lot of, most of what you said, I completely agree with. I think our liver is associated with a conscious inner life, a conscious perspective that is dissociated from the ego because evolutionarily it makes sense. We do not need to have explicit introspective access into the mental processes that underlie liver function, because the liver it needs to do what it does all the time anyway. It doesn't require explicit decision making, weighing of possibilities. It just has to run. So it's evolutionarily effective that it be dissociated from the ego and does not require explicit decision making and ego intervention to do what it does. It would be like if breathing were not automatic and we would always need to remind ourselves to breathe. Imagine how precarious that situation would be. I mean, there are animals that do not breathe automatically, like dolphins, cetaceans. They need to have explicit egoic control of their breathing. But why? Well, because they are underwater. If they would breathe automatically underwater, that would be a problem. But for us, such is not the case. So I think everything in the human body is an appearance of mental processes. I think every living being that metabolizes is the appearance of a sort of private conscious in their life. Even amoeba, even paramecium, even single-celled organisms. I have a cousin, you may actually have heard of him, Stevens Rehin, who works with brain organelles in general, but mainly brain organelles. I never had this discussion with him. He lives far away. I haven't seen him in years. But I think even those brain organelles on a Petri dish have a conscious perspective of their own. And you, in the beginning of your answer, you explained why. You basically explained that if we have reasons to think that consciousness underlies neurons, then for exactly the same reasons, whatever they may be, we have to arrive at the same conclusion tentatively for every type of cell anywhere in the body. I agree with that. There is one thing Amir mentioned. He framed the question as, could we be just a sort of a collection of conscious inner lives that reassociated? I don't think human beings require reassociation because we have never been dissociated. When we get dissociated, we speak of cancer. But from birth, we just grew. We didn't dissociate in order to need reassociation. I think individual cells are just what our inner structure looks like. I don't think one neuron in my brain has a separate point of view than another neuron. I don't think there is anything it is like to be a single neuron in my brain. I think there is something it is like to be Bernardo. And if Bernardo gets cancer, there will be something it is like to be the cancerous mass. I think that is the dissociation. I am sensitive to the existence of chimera. We talked about it last time, Michael. Chimera, just for the benefit of everybody else, is when two early stage embryos sort of fuse and give rise to only one organism instead of two, even though there are two different sets of DNA. Chimera obviously exist. They are almost common in cats. They can be induced artificially. I see that as two mental processes that were originally dissociated, associating with one another. And I think that is possible because everything is happening in one field. Dissociation is an epiphenomenal, and epiphenomena can be reversed, can be stopped. But I don't think that changes, at least my own reasoning about our being unitary organisms, because we are not chimera. And there are many, many, many living beings, the vast majority of them, who are not chimera. So I don't think they are a reassociation of anything, because I don't think they ever dissociated internally, other than at a very mild level, such as the dissociation between my ego and whatever mental processes underlie my liver. That's a mild dissociation that has no morphogenetic implication. Anyway, that's how I see it. But one last comment. You suggested that there could be private inner life associated with non-biological substrate. I think that it is impossible to refute the possibility a priori. But I'm too familiar with how AIs work and computers work to really take that possibility with any degree of seriousness. I don't think computers are in any way even remotely comparable to biology. They are mechanical. They are mechanisms, fairly simple mechanisms. The complexity of computer comes from adding more and more gates, but the fundamentals are extraordinarily simple. We only do computers with electricity and silicon and metal because it's cheaper and smaller. There is nothing fundamental about electricity and silicon and oxides and metal. We could do the whole thing with pipes, water, and pressure valves. You would get to a computer the size of the moon, which is not very practical and not very economical. If we want to put it in our pockets, it needs to be silicon, metal, and electricity. But that's the sole reason for electricity. There is nothing really magical about electricity. So long as you have gates that can open and close according to a stimulus on their base, that's it. You can do that with pipes, water, and pressure valves. So I don't think AI will be individually conscious in the sense of having private conscious in their life. But I think consciousness, not necessarily private, but consciousness as a substrate underlies all of nature, including all computers. The difference I like to make is sometimes we speak of a thing or another thing being conscious or not, and we forget that we already make a mistake by considering things as separate from their surroundings, because most things are not ontological entities separate from their context at all. Thingness is nominal. It's something we impose on our environment out of language, out of the need to communicate. So I need to, if I want to move around sitting in a metal box, and I want to acquire that metal box that allows me to move around, I need a name for it. I call it a car. So I can go to the car shop and get myself a car. But there is no car separate from the road and the gravity and the air that cools and allows for combustion, and the tires that grip the road. Without the road, the car would not move. Without gravity pulling the car to the road, the car would not move. Without the air facilitating combustion, the car would not move. There is no car. Just as it's all nominal. Like, is a table a thing? So does a table have a private conscious in a life of its own? If you say yes, then what if I remove one of the table's 4 legs? Now, does one of the table's legs acquire a private conscious in a life of its own, separate from the rest of the table? And what if I nail the leg back? Does it all merge again? If a rock detaches from the face of a mountain and comes bouncing down the side of the mountain, does it dissociate every time it bounces up and reassociates every time it touches the mountain when it's bouncing? If the river is conscious, is the ocean too? Are they separate? Where does the river end and the ocean begin? So we attribute to the world an ontological structure that only exists in language. And we mistake the structure of language for the ontological structure of the world. On that basis, I would say, there are no computers. There is just the inanimate universe. The computer as a separate thing is a language artifact, just as the rock bouncing down the side of the mountain or the river merging with the ocean. It's a language thing. But living beings, now they are not language things. Because if you stick a needle on the chair I'm sitting on, I don't feel it. But if you're sticking my arm, I feel it. There is an there is a non-subjective, non-nominal, non-arbitrary way to distinguish the boundaries of living beings. And there is none for a computer and inanimate objects. I mean, I'm not asking you to agree with this, Michael, but I'm just sharing with you how I think about this.
Yeah, no, I understand. Very interesting. So a couple of things. I agree with you that rocks and tables and things have, if any, vanishingly small of what we're talking. We can discuss later if it's truly zero. I actually don't think it's truly zero, but let's say it's epsilon, like vanishingly small. And for me, that's because their ability to pursue goals within a cognitive light cone is almost zero. They do a few things that we can talk about in terms of least action principles and things like that, but basically they are not impressive goal seeking systems. And what's interesting about life, to me, is that I think what we call life are those systems that actually scale up these incredibly tiny capacities for least action, for active inference, and so on that exist at the lower, in particles, and so to scale them up to a much bigger cognitive light. A pile of a rock it really has not scaled anything past the competency of the individual atoms that make it up. There's no scaling that's taken place. It's bigger, but that's it. Whereas in life, what you actually have is a much bigger cognitive light cone that can pursue bigger goals in other spaces. And so that's what I think is interesting. And that's why, I'm not too worked up about rocks and tables, but I agree with you also that today's computers and AIs are probably extremely low on this, if not zero on this scale. I don't think we have any impressive computers that do anything with this yet. But I'm not sure that we couldn't, and the reason that I'm not sure that we couldn't is that the same argument, if we use an argument that says that they're machines that follow simple rules, if you take apart a paramecium or a fertilized human egg, what you're left with is really some we don't know all of them, but we're getting there. Some low-level rules that the components follow, right? And somehow slowly and gradually over 9 months plus whatever, you somehow get from this system that follows pure mechanical rules that people, biochemists treat it as a machine, and they kind of work out the rules and so on. And then somewhere you go from there to the kind of cognition that we all enjoy. And it becomes really hard. In fact, developmental biology offers no place to put a magical line and say, here's where you went from physics to, from simple rules to cognition. So we need to be able to deal with this continuum somehow. And I want to tell a little story about early embryogenesis that gets to what you were saying about the chimera issue, which is quite important. So here's how we all start our life. Single fertilized egg cell. Well, first a quiescent oocyte that's just sitting in a little blob of chemistry, but then it gets fertilized, and you have a single cell, and then it starts to divide. You have a bunch of cells. At one point, let's look at amniotes, so humans and birds and things like that. You have this flat blastodisc, and it might have, let's say, 50,000 cells. So it's like a little, it's like a flat frisbee, basically, with 2 cell layers, and it's maybe 50,000 cells. So we look at this thing and we say, oh, there's an embryo. And we know that under normal circumstances, it's going to give rise to exactly one human. But what is there one of? When you look at this thing with its tens of or hundreds of thousands of cells, what is there one of? Well, the fact is, what there's one of is a kind of alignment or commitment that all of these cells are going to take the same journey in anatomical morphospace from this flat simple thing that's a disk all the way to, and by the way, their navigation, they will have to make decisions during that journey. They will have to they're able to solve problems if you interrupt it and interfere in various ways. They can solve all kinds of novel circumstances to get to where they're going. But here's the interesting thing. If we take, and I used to do this as a grad student in duck embryos, because you can do this. You take a little needle, and you put some scratches into that blastoderm. Let's say you put 2 scratches in, now you have 3 islands. So what happens is, for the next 4 to 6 hours, each of those islands doesn't feel the presence of the others. And what the cells do is they will self-organize into an embryo. And because that's what they do, because collections of cells have to self-organize into an embryo. Now, 4 or 6 hours later, they heal up. And so now what you have is conjoined twins or triplets. If you don't let them heal, you'll just have monozygotic twins or triplets or whatever. So it's quite interesting for a number of reasons. Number one is the number of humans that come out of an embryo is not fixed. It's not determined by the genetics. It could be 0, it could be 1, 2, up to, I think, 16 or probably more than that. So that's interesting. The number of you have this like excitable medium, and from that excitable medium, self-organize some number of full-on human personalities that are going to be distinct from each other. They can, right? And it's up to you as the experimenter how you cut up that blastoderm. So that's the first thing. The second thing is that each of these, what they're doing is they're figuring out the border between them and the outside world, because every cell is some other cell's neighbor. You don't know a priori when you come into the world. You don't know as an embryo, and there's some amazing examples in Salamander and others where you can vary all kinds of stuff. They're just crazy novelty for these things, and they still figure out what to do. You don't know where you end and the outside world begins. And so when you have 2 embryos sitting next to each other, there are cells that have to figure out, am I the left side of this guy or am I the right side of this guy? And sometimes actually they make mistakes, and that's how you end up with laterality defects and conjoined twins and so on. But putting that border between them and figuring out, okay, functionally, this is where we are. Everything out there is outside world. And as Bernardo said, the very important consequence of this is that if cells get that wrong, that's how you get cancer. So cells that disconnect from that information structure, to them, the rest of the body is just external environment. Their cognitive light cone has shrunk drastically from being a nice big organ or a nice embryo down to the tiny goals of a single cell. So we all come from this process of individuation from this excitable medium that potentially could have had many of us in there. And some of that remains in our lifetime. So it's known now that your right hemisphere and your left hemisphere don't share the same opinions. So if you both from split brain patients and from sodium pentothal injections, if you quiet down your dominant language hemisphere and ask the other one to write down some answers, you'll be surprised at what's going on in there. It's not necessarily things that you know about or agree with. And yeah, I think so. In my view, we are a patchwork of nested selves, some of which are extremely primitive, some of which are more, sort of more advanced, but they all operate in their various problem spaces. They all cooperate and compete with each other. Even organs in the embryo compete with each other actually for resources. And to the extent that we have an inner perspective, these other systems that also have to fight for homeostasis and meet certain goals, I think they do as well.
I was fascinated by when you told about scratching the embryo in two places to create three different individuals. Under analytic idealism, your scratching that embryo is a dashboard representation of what is fundamentally a mental process. In other words, the scratching is not fundamentally physical. It's just a dashboard representation that we call the physical scratching. What's actually going on is a process of mental interference. And I don't find it surprising at all under the premises of analytic idealism that mental interference with an embryo can lead to further dissociative levels, that further dissociation can be induced in that embryo through mental interference. And that interference is what would then appear on a dashboard as you're scratching the embryo, if you know what I mean. I mean, the same goes for a surgeon coming with a scalpel and dissecting your corpus callosum. That physical cutting with a scalpel is the image, the dashboard representation of a mental process that induces dissociation even in a grown adult by severing the corpus callosum. So I have zero problem with that. I think most of us tend to think of individual separate identity as something very fundamental. Even analytic idealists, I think, tend to regard it that way, like, oh, this dissociative process in nature that leads to individual identity, it's something heavy, important, fundamental, a primitive of some form. But now, under analytic idealism, personal identity is merely epiphenomenal. It doesn't really exist. It's just a lack of associative links that leads to the impression of personal identity. But because we are invested in our personal identity, we think it's something very fundamental, very significant, very important in nature. It may be important in many different ways, otherwise nature wouldn't be creating life everywhere it can. So as a whole, this dissociative process that we call life, I think might be very important, significant, but that doesn't apply to any individual life. And nature, again, provides the clue. Nature doesn't seem to be very worried about any particular individual. It seems to be much more invested in the existence and the spread of life and the variety of life, as opposed to individuals. Individuals come and go all the time. They are part of something significant, but I don't think they are significant in themselves. So that we can, with a needle, induce dissociation, or through other, laboratory methods that you know very well, that we can sort of reassociate things that were dissociated, I think it's perfectly reasonable under analytic idealism that such should be possible. I don't have an issue with that at all. So in other words, I'm with you there. Regarding the goal seeking, I'll share with you my underlying thought as opposed to just the conclusion. My underlying thought is a perennial concern to distinguish between something that's natural and something that is just an imitation created by us. I can create a computer tomorrow that will seek its own goals, but it will do so because I either constructed or programmed it to do that, directly or indirectly. In AI, people say, well, I didn't program the AI to do that. No, you did. When you applied, back propagation to do the training of your AI, you did exactly that. It's just that you were not fully aware of the implications of what you were doing. That's all there is to it. That's the black box of AI. We are not fully aware of the implications of what we are doing, but we did the whole thing. To give you an example, so you understand more viscerally what my concern is. When we create shop window mannequins to display clothes, they look like us. So there is a certain isomorphism between us and the shop mannequin, but that doesn't allow us to attribute to the shop mannequin everything that nature attributed to us. Why? Because the shop mannequin is an imitation. It was made to be similar. It didn't arise out of nature in a similar way. If it had, then we could start asking, well, what are the other correspondences between what we are and what this thing is? Because they naturally arose in a way that is similar, or they look similar. But for a shop mannequin, no, it's similar because we imitated it intentionally. And in the same way, we can imitate goal seeking by constructing hardware or programming it in a way that will make it seek goals in a manner analogous to how we seek goals. But just as for the shop mannequin, how much can we derive as implications from this? Because it was made to look like it. Can we start deriving too many implications out of that similarity that is artificially induced? That's my concern. I'm not arriving at any major conclusion out of this, but so you understand where I'm coming from.
Yeah, no, I understand. And the question of where do goals come from is really important, and we can talk about that. I think that I agree with you. I mean, of course we can make different kinds of mannequins and be fooled and so on. But fundamentally, if some aliens showed up tomorrow and said to me, hey, guess what? That oocyte you came from, we put that together. We put that together piece by piece, right? Just like you guys put together computers. You're just primitive. We put it together. And by the way, we put in, we're so smart. We put in some stuff that was pretty much guaranteed to give you some goals about being a scientist and whatnot, and so on. And so, right. So there's this whole origin story of, I wouldn't. There's some people, and I get emails from people that are very destabilized by those kind of stories. I wouldn't be. I would not from that conclude that, oh my God, I'm a mannequin, and what do I do now, right? Which no problem. Fine, that's my origin story, but that's okay because whatever they did constructed what I am now, and I'm going to go on with my life and do whatever it was I was going to do before then. It's interesting, right? Different people so even in there's many of these, but like that movie Ex Machina, where the guy at one point he gets really disturbed by what's going on and he starts cutting his arm in front of a mirror because he's worried that he's going to find that he's worried that he's going to find like gears and cogs in there. I look at that and to me, okay, if one day I open my arm and I find gears and cogs, my conclusion isn't that is not that I'm not real. My conclusion is, wow, gears and cogs can make this amazing, conscious thing. Fantastic. So
I'm completely with you there. I actually think we will be able to create artificially dissociated consciousness, but I think it will look like life. It will look like a cell. It will be something you would do, or Craig, what's his name again? Craig
Ventner, yeah.
Craig Ventner would do. Because nature is telling us that metabolism is what this thing called private conscious inner life that we know we have. it is associated with metabolism. And whether it's artificial or not, it doesn't matter, because the datum is that private conscious inner life seems to come paired with metabolism. Whether it's natural or not, it doesn't change the empirical data, right? And I think that's the data, that private conscious inner life comes associated with metabolism. Whether it's artificial or natural, it doesn't matter. The association is there. That's what we know. What we don't know is that electrons flowing through metal traces and opening or closing silicon and oxide switches also correlate with conscious inner life. That's what I mean. My point is not against artificiality per se. My point is, I don't think we have good reasons given by nature to think that something that isn't metabolism can also be associated with conscious inner life. Maybe it can. I cannot refute it. Yeah. All I'm saying is I don't see good reasons for us to think that. It's more or less arbitrary because of this idea of imitation. As for the aliens, that will not change my perspective on life at all, just like you. Because, you know, if it wasn't aliens, we have almost just as discombobulating a problem to make sense of the fact that we can think symbolically and the rest of nature can't. It's just as discombobulating as the aliens having engineered us. So when that news comes out, I will not be fazed for the least. No problem at all.
Yeah, I agree with you. I think we're saying the same thing in that I agree that if we were to make things that obey the key principles, and you call it metabolism, which is fine. I think of it as a form of self-construction or autopoiesis, of which metabolism is kind of one version. And anything that does that, you might just say, oh, well, what you've done is you've made life. And I agree with that because life, I think life is what we call things that have that process of self-construction, which our current, most if not all of our current artifacts don't do. That existential beginning where they have to define themselves as different from the outside world. We don't have anything like that. They have to battle for energy, and which really makes it essential that you learn to coarse grain and tell causal stories about agents that do things. You can't you don't have time to be Laplace's demon. You have to just sort of, right? Or like all of those things are essential to having a proper inner perspective. So yeah, I think we're on the same page there.
Yeah, I go along with that. My perennial concern is to distinguish this as a true phenomenon or this as just an artificial appearance created for imitation, like the game of life, that cellular automaton that creates the impression that there are organisms striving to survive, while in fact it's just two very simple rules being applied to grid. And that
the thing with the game of, so that's very interesting. The thing with the game of life, though, to me, is not that it's got simple physics, because we maybe have the simple physics underneath too. The thing about the game of life, and actually it's interesting because we've been playing to try to change that. The thing with the game of life is that it's an open loop emergent system. You follow the rules, but there are no goals being maintained by any of the systems. They just, exactly. Whatever happens.
But it looks like there is.
Correct. And so the key in my framework, one of the key tenets is that you cannot determine agency by pure observation. No amount of observation will tell you what's going on. You have to do perturbative experiments. So you got that glider coming along, you put a barrier in front of him, and you ask, does he know how to get around? And the weird thing is, and I think this is something, I don't know if this is a good venue for it, or maybe at some point you and I should talk about this separately, but we've been studying, so I like finding these kinds of competencies in extremely simple systems. Okay, and so we've been studying simple sorting algorithms, like bubble sort, that kind of thing, right? That people have been studying for decades. All the students sort of use them. They have some interesting properties in that respect. If you plot out their path through the sorting space and you start doing the kinds of things that we do to test IQ in animals, you put barriers, you see, can they go around? Do they have delayed gratification? Do they have, there's some interesting stuff very early on in these extremely simple systems. And so I think that I agree with you that the game of life has no chops in this matter, because what you need to do is you need to perturb and look for problem-solving capabilities. But I think we are going to be extremely surprised at how early and how minimal we find some of this. I think we're poorly calibrated. We look for complexity. We think, I think there's some major, and already people are, are finding this in terms of active matter research and things like this. A few more years, I think we're going to have some amazing examples of it, very low down.
I agree with you. The answer is not in complexity.
Yeah.
Is it okay just to clarify and just drill down on this? So, but Bernardo, you're saying the sign or the outward, what dissociation looks like is metabolism.
That's the data we do have. Yeah.
Right.
It doesn't exclude other possibilities, but it's the data we have. Yeah.
Yeah. And Michael, you were describing how a cell initiates, and at some point it's explainable purely in terms of physics. It's like almost a machine, and then at some point something happens. Is that related or correlated with metabolism, or?
Yeah, what I'm saying is that unless we're prepared to throw away physical closure, which is a whole other thing we could talk about, but let's assume that the physics is what we think it is, which means that when you look at a paramecium or a human oocyte, all you're going to find is chemistry. And at some point, we're going to have all the rules. We may already have all the rules. And so what you can't say is that there's some sort of extra magic there because it is protoplasm versus something else. You can't say that it's because it follows, it doesn't follow simple rules the way that some of these other systems do. That can't be it. So what is it, right? So Bernardo points to metabolism, which is quite reasonable. I sort of generalize that by saying that what is really happening is a scale up of goal-directed algorithms, and in other words, processes, I should say. So the kinds of things that are able to reach specific regions in the problem space despite interventions. That's when I say goal-directedness, what I mean is William James's definition of intelligence, which is same ends by different means. You got a system, it's operating in some problem space, and it's going to get where it needs to go. And if you deviate it, if you start it from a different position, if you put a barrier in it, if you make changes, it has some degree of, proportional to what we recognize as intelligence, it has some degree of getting its job done, even though you're messing with it. That property starts very early on. Simple molecular networks have variants of this already, so you don't need too much to get onto that ladder. And the things we call life are the things where those competencies add up in a very interesting way that's not linear, that's not just what pebbles and rocks do, but actually where those goals, the things that they are trying to reach, become progressively larger. So if you want, we can talk about my concept of the cognitive light cone, but the idea is that it isn't just about complexity. It isn't about feed-forward emergence. I mean, that's easy. It's fractal is a game of life. It's easy to get complexity from simple rules. It is the emergence of goal-seeking agents, of which something like a thermostat is an extremely simple early example, but they are fundamentally different from systems that don't do that because they offer a different interface. And here again, I think Bernardo said a great thing, which is this what do you call it, a dashboard or no?
Dashboard metaphor.
Yeah, dashboard. This is exactly right, because this is how I encourage my students and postdocs to think about the biomedicine that we're doing. What we are doing is we are manipulating. We are trying to, if on a good day, what we are doing is we are really using everything that we know from about how these things work. So all the bioelectrical components, the biomechanical, biochemical, we are using them as an interface to try to manipulate the memories, the goals, and the preferences of the biological system. So our goal is not to try to micromanage, let's say we want limb regeneration or something like this. We're not doing the 3D printing thing where you try to put every cell where it goes. Your goal is to get the buy-in of the cells that actually where they need to go in morphospace is not the region that corresponds to scarring and cessation of growth. They need to go back to that limb region. And so you are literally, it's a communication event more than it is any kind of a forcing. But the techniques you have available to you are radically different depending on what kind of system you're dealing with. And if you're dealing with rocks, all you've got is potential energy and hammers. Like that's it. That's basically your toolkit. But once you have thermostats, amazing things happen. That means that you can now rewrite the set point. You don't even have to know how the rest of the system works. You don't have to re-engineer the rest of the system. You can take advantage of the fact that it is good at following that set point. You just and it also tells you there's a whole new set of mistakes it can make. There's a whole new set of malfunctions having to do with errors of perception, having to do with errors of execution, and so on. So for me, that early step, metabolism, is a part of it, but it's basically that scaling up of goal state from the extremely primitive least action and free energy kinds of things of molecules into what pathways, cells, tissues, organs, humans, and so on can do.
I might want to comment briefly on this. I'm not going to say this just to put you up, Mike, just to please you. It's not just to please you, it's because I think it's very important. What Michael has just described is a fundamentally different paradigm than what we have been mostly used to since the Enlightenment. What we have done so far is to think of everything as a mechanism and impose our will on these mechanisms down to the last subatomic particle. We want to 3D print nature exactly the way we want it to be. That's not going to work. What Michael is describing as a process of communication is very different. It is a kind of collaboration, a cooperation with nature, where you help nature see where it wants to go, and it will do everything by itself. We don't need to 3D print it. It's going to do it if we just engage in a constructive collaboration, an artistic collaboration with nature, wherein both our will and nature's will collaborate towards a common goal. This is a completely different paradigm of thinking than what we are used to. And all I can hope for is that there will be many, many more Michael Levins around not too long from now, because that's the only way to progress. It's this kind of thinking, this kind of perspective that will lead us to the cure of cancer and many other things.
Yeah. Well, and I want to say that that general idea, while it's completely new in the sort of the scientific realm, and most people actually don't the molecular biologists and so on don't like that at all. That general idea has been around for a long time in what you might call, let's say, the alternative health community, right? So there, those folks who work on that stuff, they've always been saying that, oh, your tissues have memories and they have intent, and we need to get the buy-in from the cells. And they've been on top of this for the longest time. However, they didn't have the mechanism, right? And so I think for the first time now, we're starting to be able to actually say, okay, let's take this seriously. And it's not the same as seeing a spirit in every rock, because that doesn't actually help you manipulate the rocks. But so we have to have a research program that actually tells you when is it reasonable to say this is the type and level of cognition that you have in this unconventional system. And now we're starting to see, and this is, you're right, of course, that bioelectricity or electricity in general is not magic, but the interesting thing that evolution has done with bioelectricity in bodies, ours and others, is that it uses it as a kind of cognitive glue. So it takes advantage of the use of electrical networks to merge individual cells with their tiny little goals into larger computational networks that have bigger goals in bigger spaces. And so now we have the interface. Now we're starting to see we actually have the interface to communicate with this and to say, I know you think your goal is this, but we're going to rewrite it. We're going to rewrite it and then go. And this is I have this really kind of gross slide that I sometimes show where people, when I give talks and we talk about whether, is the body a machine? I'm like, look, here is the way orthopedic surgeons see it. And I've got this picture of this, he sent it to me and he allowed me to, show it to others. It's a picture of a guy's arm. It's opened up like this in half. And there's a bunch of screws, and there's somebody with a hammer, like banging the screws in, like, yeah, that is how you work with a machine. So there are some things that are very sort of low level kinds of stuff. But after that, what happens is they put all the bolts in and everything else. They sew it back up, and then they send you home to heal. And what's that? That's the part they can't micromanage. That's the part that where everything else is going to get, and we have all kinds of examples in the lab where you sort of smash some stuff together, and over the next few weeks, everything sort of sorts out and becomes nice and even and nice and smooth. We have no hope of controlling that bottom up. That has to be a motivated process. And at the end, you see this guy's arm and it's working really well. And it's got a nice, very, very light, sort of scar, but everything else is that's the healing part. And so we have in biology now some of the interfaces, and I really do see this as a communications, and the question is how high can you actually go? This was kind of amazing. I was talking to somebody who's not in this field at all. I think it was in finance or something, and I was explaining this idea that we don't want to micromanage stem cells or anything like that. We want to sort of go to the next level and reset these goals. And he said, well, why do you stop there? Why don't you keep going? And what's above that? And there's some very interesting stories in the field of hypnodermatology and something like this, where actually, there are actually levels above this. We don't know how to access them yet, but it's pretty clear that our multi-scale architecture that we're built of has numerous levels besides this molecular biology that we've been in love with for decades.
You're referring to curing warts through hypnosis?
Well, not just warts. So I'll tell this very, very brief story. There's this guy, and you can find there's a set of 4 lectures by him, or interviews, I guess, Albert Mason, and it's online. Super interesting. So this guy, he was an obstetrician in I think the 50s in the UK, and he was delivering babies. He was using anesthesia, and he didn't like it because it suppressed breathing in the babies, and he wanted to get away from it somehow. And so he decided he was going to try hypnosis. So he tries hypnotic pain relief, and it works, and he's delivering babies. And one day, and his colleagues are kind of making fun of him because it's a unusual approach. And one day they say, well, you think hypnosis is so good? Here, try this. And they give him a patient. He's a young teenager who's got, I forget what the exact name of the syndrome is, but it's something ichthyosis. It's really just, his arms, the skin is just black and cracking. It's just a terrible skin disease, right? So he says, I don't know. All right, I'll try it. And he gives him so he puts him under. He gives him a hypnotic suggestion that one of the arms is going to clear up. One. And then there's a nice paper that you can see where it's got the photograph of him afterwards. And guess what, right? And so from then on, he says, oh, I see. So we can actually use the interface of the patient's nervous system to go from this high level verbal sort of suggestive interface down to the molecular, whatever cues it's needed for these cells to normalize and new skin cells to appear and whatever. So he goes and he has several decades of success in hypnodermatology, treating all kinds of diseases and so on. And then he quits. And the reason he quits, and this was the most interesting part of the talk. The reason he quits is because he noticed the following: that his patients, their skin issues would clear up, but they would acquire other problems. So they would start smoking, they would start to be mean to their spouse, something else would happen. And he eventually became a psychoanalyst and a therapist, because he hopped 2 levels. He went from the cellular signaling of skin up to that kind of interface, all the way up to where he then thought, after watching these patients, and sort of he felt that it was like pushing the pile under the rug, right? You sort of smash it down one place, you've got the buy-in of the cells, and so they're going to normalize, but you haven't got the buy-in of the entire organism. And for whatever complicated, and I'm not an expert in any of this, so I'm just sort of telling you what he said, for whatever complicated sort of holistic reason, it's going to pop up somewhere else. It's going to pop up in behavior or a digestive disorder. This is something else, and that he felt that the way to clear this up is really, he was sort of aiming at as high as he could, right? So I think that's really interesting. And just the last thing that I'll say is this, because when oftentimes when people hear like hypnodermatology, they think, well, it's some sort of like really rare and unusual mind-body medicine, some sort of yoga or some kind of biofeedback or something. It's it's a rare, weird thing. Well, just realize that every time in the morning when you get up, when you wake up and you think to yourself, I've got all kinds of financial career and scientific goals. I'm going to get up out of bed, go to the wherever, and I'm going to do my job. For you to for that high level executive intent to make you actually get up out of bed, it has to get transduced to the movement of potassium and sodium ions across your muscle membrane. That mind-body interaction is happening 24/7 in your body. It's not some rare, weird, controversial thing. It's the way we walk around all day long, right? This high-level cognition through the bioelectrical, and it literally is a bioelectrical interface that converts. It's like a transformer that converts from that level of intent down to, okay, now you better move some potassium ions across that muscle, otherwise you're not getting up. So we are an amazing integrated system, right? That works across these levels. And if that's true, then surely the molecular level is not the only level to do biomedical interventions. So that's how I come at it.
Fascinating.
Great.
Michael, if you ever want to publish anything and you don't have a publisher, please remember us at Essentia Foundation. We have a book in print.
Cool.
We invest quite a bit in promoting our stuff.
Super cool. Yeah. Let's talk about it. I've got a lot of stuff. The biggest barrier right now is time. Everything's backing up. I don't have time to write the things that need to be written. But that sounds great. Let's talk about it.
We do one big book a year. We do several books, but one big. So next year it will be Federico Fagin's Irreducible.
Cool.
You probably know Federico, right? The inventor of the microprocessor, silicon gate technology.
Yep.
Maybe you could do one by you in 2025.
Okay, let's chat.
This big book means we really do a lot. We're going to do a lot with Federico next year to promote the book. No hope of ever recouping that money, but we are a foundation. We are not for profit. That's not how we operate. I would love to publish something along the lines of everything you said today.
Okay, let's chat about it afterwards. Cool.
Great. If there's time, I really want to bring in a question from the audience, but I do see several comments in the chat where people are very keen to hunker down. So I'll just see if I can express one thing that I'm not super clear on, which I've understood that you both agree it's possible that aliens could come down, that the origin of our cell, whatever the original cell, whatever we are, could have been aliens that combined various bits of physics and chemistry into life. And I also think I heard you both agree that, hey, if one day we open up our arm, we're made of cogs and metal, that's also conceivable. I've understood you, Bernardo, to say, look, there's no way computers could ever be conscious because you could conceivably build a computer out of like pipes and water or whatever. But I'm also hearing that it's conceivable we build life out of also like, bits of metal, cogs. So it's still, again, maybe I've misunderstood one or both of you, but it still sounds like, Bernardo, you don't conceive that computers could ever be conscious. And I'm hearing, Michael, you suspect that they could be because you see how the original cell is just mechanics at one level, and something happens and one day we'll figure out what that is.
I think, just to clarify my position, I don't think computers as we understand them today, I don't think we have any good reason to think that they might have conscious in their life, because their isomorphism with us, their similarity to us, takes place at a very, very, very high level of abstraction, where you're forced to ignore all the drastic differences between computers and us and find a similarity at a very high level of abstraction. I don't think we have good reasons to think that computers, as we understand them today, could do that. My understanding of Michael is that there are some goal-oriented, self-organizing principles in nature that express themselves in the form of life, but maybe they could express themselves in another form. Am I open to that possibility? Yes, I'm open to that possibility. I don't think that other form will be computers as we understand them today. But today we are also thinking about neuromorphic computers, which are no longer digital. They are now analog. They use electricity in a continuous manner, not only to open and close gates. Do I think those are conscious? I still don't think they are not. But if we pursue that direction with more insight into the basic organizing principles of nature and whatever goal orientation there might be there, it is conceivable that one day we could do something that has private conscious in their life and does not metabolize. I don't think we have good reasons to think about that, to think that today, but it is conceivable long term. So that's my position.
Yeah, and for me, I'll just say that okay, so we have to be able to say what is the special criterion that rules something in or out, right? For this kind of thing. And I completely agree that today's computers don't match it. But what it is, I don't think it's the material. And I don't think it's whether it was engineered or naturally evolved. I don't think those two things are what make the difference. I think what makes the difference is a particular, there's a few things, in this, but chief among them is this process of autopoiesis, this fact that it has to be a system that puts itself together, that struggles with the existential question of where do I end and the outside world begins, physically, not cognitively, but physically, it struggles with that issue. It's a system that has to fight for survival by in terms of energy limitations, which force a particular kind of model of itself in the world. Those kinds of things, I think, could be implemented by many different media. Today, we don't have any artificial systems that do it, but at some point we probably will. And that's where I think the magic is. I think the magic is in the origins. It's in the self-construction process. It's not in the material.
And on the question of aliens, just so people don't walk away thinking that I'm, going down the deep end. The hypothesis there was not that aliens created biology. The hypothesis there is that, okay, there is biology on this planet. It's natural. It does what it does. But there is this one animal species that somehow is not connected into the web of instinct anymore and can think symbolically. In other words, we can replace elements of reality with concepts and work out those concepts to impose our will on reality back again. This is pretty unique. Do we have any reason to entertain the possibility that this particular mutation might have been artificial? Turns out that we may have some reason. There's a book by Ian Tattersall called Masters of the Planet, where he basically explains that mutation that allows us to think symbolically is there already for at least 100,000 years. But we only have anthropological evidence or archaeological evidence for it back 30 or 50,000 years. In other words, there is at least 50,000 years, if not 150,000 years, in which the mutation must have already been present, but didn't manifest itself. It was not used. Now, this is not any mutation. It's the most spectacular mutation in the history of life on this planet. And it happened without providing any fitness advantage because it lay unused for 100,000 years or more. So Ian Tattersall concludes by saying, the only reason we have to entertain this hypothesis at all, to think that this could at all be possible, is that it has happened. If it hasn't happened, we would just dismiss it as complete lunacy because there is just no reason for the most significant mutation in the history of life to have happened without providing a fitness advantage. And not only did it happen, it was affixed in the genome of all of us, the entire species. What the hell is going on here? This is discombobulating. So if somebody from the government tomorrow would come down and say, well, we've known now for I don't know how many decades that the aliens did it, they introduced this mutation. One, nothing would change as far as my understanding of myself and my self-valuation. I would still be me, and I would still be as valuable or non-valuable as I am today. And two, I wouldn't consider that news more discombobulating than the alternative. The alternative is profoundly discombobulating.
I'm gonna do a question from Lisa, who's asked me to read it because she's unavailable right now. So, ethical implications of Michael's work. Michael, have you been surprised by your own discoveries, and have they changed the way you perceive and relate to the world? What ethical obligations do you think might be inferred from the awareness that cognition is far more foundational in biology than we thought, particularly towards lower, in quotes, species such as your flatworms and frogs, and even plants and insects?
Yeah. Yeah, absolutely. And let's see, a few things to say. First of all, we as humans have a long history of ethical lapses due to extremely small and superficial differences. Okay, we are very happy to hop onto the tiniest distinctions between in groups and out groups to behave in a fairly atrocious manner. And so I think that this is an even more all of the work that, and it's not just me, but it's all the people that are doing that are doing human augmentation, so repair, but then augmentation, and then the cyborgs and the hybrids and everything else that's going to be coming down the pike. We are going to absolutely have to develop new frameworks for ethics that do not depend on the old school versions that we used to use, and we use them poorly. But where did you come from? Meaning that were you naturally evolved, or did you come from a factory? Right. So you in the past, you see a new system and you can basically just like knock on it. So you knock on it. If you hear a hollow metallic sound, then you can conclude, you came from a factory. You're going to be rather boring. I can do whatever I want to, and it's all good. But if you hear like this soft sort of woolly thud, then you say, okay, well, at least so you're probably going to be interesting. You must be, you must have been naturally derived. At least in theory, I'm supposed to be nice to you, unless you're delicious, in which case I'll, I might eat you. And so, right. So we had these, this way of, those things are out the window. In the next decades, we are going to be surrounded by agents that are nowhere with us on the tree of life. You are not going to be able to look at something and say, that looks like a fish. I know how I deal with fish. Not going to work. We are going to have to radically, I've called it a kind of a synthbiosis, where we are going to have to learn to relate to these things who have bodies and minds that are not like ours at all. And I think for maturing species, that's essential. We are, in the future, we are going to have to get rid of this idea that things that are precisely like us are the ones that deserve some kind of moral consideration, and we're going to have to base it on something else other than, do you have a frontal cortex that looks like me? Do you have a overall body shape that looks like me? Do you have genetics that look like me? All of this is garbage. It has to go, and we're going to have to develop a new way of dealing with, and of course, people in science fiction have been at this for many decades. This issue has come up long before. Which is why, again, the whole alien thing, not because I know anything about aliens, but just this notion of, when you are confronted with a radically different life form where you cannot assume anything about its construction or how it got here, how do you decide what your relationship is going to be? And this has massive implications. And yeah, I've been doing the best I can and sort of explicating some of that in our work, but it's going to change everything. All of the discussions, and I've had a number of discussions with people who do in the areas of law and things like that. When they say the human or the human brain, that category is going to get so soft, it's going to be ridiculous. And it's not just because of LLMs and AIs. Just the amount of modification and the improvements that are going to be made in our really pretty shoddy in many ways architectures are going to make it clear that what human, and you can, I did a homeschool thing with my kid where we did this project where we created a survey and we deployed it online, and like 400 people took it and whatever. And one of the things he wanted to do was he wanted to ask, so we have this, like, evolutionarily, we have this backtrack from modern humans to however far back. And you just ask yourself, like, which of them would you be able to drag into court and cause, and say that they were responsible? Like, at some point nowadays we do, but when did that show up? You go far back enough and you just say, well, that's a wild animal. He doesn't know what he's doing. But at some point that peters out. And so this notion that we have some sort of a sharp category that, okay, that one right there is responsible for his actions. And if you sort of deviate from that, either anatomically or in other ways, then that's not, all of that's going to get completely turned upside down by the field of diverse intelligence. So.
Feel free, Bernardo, to comment if you want.
Oh, I think you're muted.
Oh, Bernardo, you're muted. Did you say something?
Oh, I'm sorry. I'm sorry. I forgot I muted myself. No, I just noticed Michael's bongos on the background. I think he plays the bongo like Richard Feynman.
I don't know how to play the bongos. No, that's just my kids come in and we make noise. That's it. I don't know how to play.
In other, you've got many talks and lectures in terms of looking at the mechanism by which cells cooperate, being a biological field. And there was curiosity in me and others of something you mentioned in some other talks of like, well, who knows, there might be higher order, we might be contributing to some higher order agent of which we're unaware, in the same way that the cells of our body might not be aware that they're contributing to the self that we call us. Do you suspect that the mechanisms by which you find coordinate cells will reveal the kind of mechanisms that we might look for in human societies or whatever, that would give us clues of like, oh, there might be a higher order agent here that we're contributing to?
Yeah. A couple of things. One is that, well, I don't know, but I suspect there's some sort of Gödel limit on us. So one question you might ask is, if you're a subunit of a larger system, can you determine that you are, and can you learn about what is the system actually doing? So I suspect, I don't know, but I suspect there are some sort of Gödel limits around actually being able to know that for sure and to really understand what the high level system is doing. But I bet you can gain evidence for it. And I have this, I work with this amazing graphic artist, Jeremy Gay, and I've asked him to draw this little diagram, this little cartoon for me, and he did. And it's two neurons inside a brain, and they're arguing. And one neuron is a reductionist material, and he says, "Look, the outside world is a cold mechanical place. The universe doesn't care what you do. Nobody cares about us." And the other one says, "Yeah, I know, I can't prove it, but really, I feel like there's an order to this. There's this like wave, that back propagates across this, and and I feel like there's some kind of larger system that has some sort of." And the force, yeah, you're crazy, you're making stuff up, and and so of course for them, the mystic neuron is in that case is correct, right? And the question is, how do you gain evidence that you are in fact part of such a system? I don't know, and I don't know if the rules of what we found out about the way that the cognitive glue of bioelectricity, the way that works in the body and in the brain, if that has anything to do with if that is if you can extrapolate that to larger scale societies and so on. But I will say this: a lot of folks, they hear my cancer talk, and in the cancer talk I go through how, okay, you've got this electrical network, and it has this pattern memory of working to be a nice liver or skin or whatever it's going to be. And then for one of many possible reasons, one or more of the cells electrically disconnect. Their cognitive light cone shrinks. As far as they're concerned, they're amoebas in this harsh external world, and they just sort of go off on their own, and they have their amoeba-like dreams of making more amoebas and going wherever life is good and so on. And so one of the things we've done in the lab is to say, okay, so as a therapeutic, instead of trying to kill these cells, why don't we try to reconnect them back to the collective? And so we've been able to do that in the frog model. Now we're trying it in human cells, but in the frog model, what we've done is to literally force these cells to stay in electrical connection with the network. And despite nasty oncogenic mutations and so on, it works great. They become part of the group, and they work on making a nice organ and so on. So people see this story, and then they contact me and they say, I got it. Here's what we're, and the way these cells, by the way, are connected with these things called gap junctions. So these are these electrical synapses. And the magic thing about these electrical synapses is that they allow signals directly from one cell into the internal milieu of the other. And so neither cell now can tell whose memory that was, right? Because these signals don't come with any kind of metadata. When you're connected like that, there's no me or you, because it's now hard to keep memories distinct. It's just we, and we share. It's like a mind meld, right? So people see this story and they contact me and they say, okay, let's great. So for society, we're just going to let's just gap junction ourselves together, and it'll be fantastic. And here I say, pump the brakes here, because one of the things about making large scale systems is a couple of things. First of all, you don't really have any guarantee that the large scale system is going to be any smarter than the individuals. Okay? There's no guarantee on that. And the other thing is that oftentimes these large scale systems, what they'll do is they'll bend the energy landscape for the components to make them do whatever they're going to do to serve the larger scale goals, but they don't often do that with any kind of an eye towards the well-being of the components. So like you and I always use the same example for some reason. If we go rock climbing and we have a great day and we meet our social goals and but you leave a bunch of your skin cells on that surface, right? You're going to rub off. You're going to lose a bunch of skin cells. Nobody asked those skin cells if this was a great idea. You don't think about how many cells you lose with all the different with all the different things you do every day in terms of things you eat and drink and so on. So there's no guarantee that making a system like that is going to be good for us, its components. And I think we generate these large scale systems all the time, social systems, financial systems, whatever, these structures, with really right now not much of a science of what are going to be the competencies and what are going to be the goals of these collective systems. We don't know. And I think it's an existential level challenge for us, for human flourishing, to really understand what that is and how these collective systems get their goals, and to develop policies, connection policies that are going to, I have no idea how to do this. That's way beyond my pay grade, but I can sort of see what needs to be done, is to develop optimal policies for informational linkages that simultaneously level us up as a collective to new capabilities, but preserve the well-being of the components. And that is distinctly non-trivial. And biology doesn't always do a great job of that, by the way. So that's what I think.
Yeah, and I suppose I'm curious as well in hearing that if that cure for cancer will be similar. I'm hoping it won't be similar to the hypnotic cure for the skin diseases. And there's some other underlying reason for the cancer, but you can use that bioelectrical intervention. Yeah.
Well, we know that. I mean, we know that induced experiential stress is promotive of cancer. So we know that certain kinds of behavioral experiences tend to actually promote cell defections from the network. I can only assume that if we knew what we were doing, there would be a way to drive them back with experiences. We just don't know how to do that yet. So we're still playing at that lower interface. But I mean, that guy was right. I think we actually could at some point jump levels up.
Do you time for one more question?
Sure.
Jeffrey?
Okay. Boy, first of all, I blame you both for being so interesting that I'm frustrated with how many questions are bubbling up inside of me as I listen, and I'm trying to pin down what I want to ask, but I think I've got it. I don't know whether I should go a little woo-woo or stay really grounded. Any feedback, Amir?
Let's see what comes out of your mouth.
Okay. All right. I'm going to avoid the woo-woo. I'll hold it for later. Michael, I'd love to know, in terms of your research, in what ways would you say what you're learning and noticing and wondering about pushes the most strongly against kind of the neo-Darwinian picture? Or in what ways is it maybe not a direct conflict, but you're in some wiggle room space of challenging it? And does that have any implications of the future of like the human body evolution distinct from all the technological gadgets people are going to be putting inside their bodies, like just the body itself evolving? Does your research make a suggestion of like a direction that was moving in? If that makes any sense.
Yeah. Let's see. I'll do the second thing first. I'm not an expert on this particular question, but my understanding is that the traditional evolution of the body for us is over. And that's because, between glasses and proper nutrition and antibiotics, all the, our reproductive success now is no longer tied so closely to all the factors that did that when we were on the savannah and before. So nowadays, I'm not at all sure that kind of, traditional physical evolution is happening to our bodies. I could be wrong. There may be examples of it, but I think we've so uncoupled reproductive success from those kind of physical factors that that game is up, I think, and from now on it's going to be a kind of intentional modification, whether by technological or biological means. But I think we're now left that land. The Darwinian thing. I will say this, and I'll just preface this by saying I am in no way claiming that there's any kind of a major direction to evolution, or there's a purpose. I'm not making any of those claims, but I'll just tell you what we did find. Here's an interesting experiment that we did. we took some flatworms, some planaria. One of the things about them is they regenerate every part of their body. They're very regenerative. And so we put them in this solution called of this stuff called barium. Barium is an element. It basically blocks all the potassium channels. So what that means is that the cells were unable to pass potassium, especially the neurons were very unhappy about this. Their heads explode, right? Over 24 or so hours, just, they lose their heads. Okay. So you leave them in the barium, and after a couple of weeks, they grow new heads, and the new heads don't care about barium, no problem. And we thought, that's amazing. Why don't the new heads care? We looked at what genes are expressed in the new heads versus the original heads. We did a subtraction, right? What's the difference? And we found there's really literally only about a dozen or so genes that are different. So now think about what this thing did. Oh, and here's the key, that as far as we know, planaria do not have a history of having to deal with barium. Okay, this is a new crazy kind of intervention that we hit them with. They rapidly the cells rapidly figured out how to do their business in a different way. Out of, I don't know, 20,000, I forget exactly how many genes they have, but just imagine there's a 20,000 dimensional space of possible things you could do. You need to find down to a dozen things that are going to resolve this new problem you've never seen before. Okay, so when I talk to students about it, I say, it's a nuclear reactor control room. There's buttons everywhere. You don't have time to randomly flip switches up, but yes, within the same generation. There is no time for trying random possibilities out of all those genes. The cells don't turn over the way bacteria do, so you can't really do it the way that a bacterial population would be, which is kill off everybody and then take the one mutant that actually is resistant and he would repopulate. That doesn't happen here because these cells don't grow so fast and so on. So what does this mean for evolution? And we don't know how general this is. I suspect it's extremely general, but we haven't proven that. Here's the problem. What the connection to evolution is. Under standard evolutionary theory, the reason that so-called strong Lamarckism is not possible. So let's remember the claim that if you're a giraffe and you keep stretching yourself towards higher leaves, your children are going to have a longer neck. The problem with that isn't what they usually say when they discuss this, which is that, oh, your germ cells are set aside earlier and things that happen to your body don't affect the germ cells. That isn't the problem. That thing has been is shown to be porous with all kinds of transgenerational inheritance mechanisms. That isn't the issue. You can certainly affect the gametes in the body. That's not the problem. The problem is that there is no single gene for most of our traits. So if you want a longer neck, what genes do you mutate to get yourself a longer neck? There is no gene for neck length. It's a combination. It's just like if you have a fractal that is made of a tiny formula and you say, oh, that's nice, I want an extra curlicue up here. Well, how do you change the formula? It's not reversible. That process development is so recursive that it's an inverse problem. You can't reverse it. So if the cells can't figure out what genes to change, then you're left with standard random mutation and selection. That's standard evolutionary theory. It's just you generate completely random variants that have zero correlation to what would be fit in that environment, and then you just pick. The selection is what generates the fit between individual and environment. However, if this thing that we're finding in these flatworms is true, it suggests that actually cells kind of do have a way of working out what genes should be up and down regulated to deal with a new stressor they've never seen before. We don't know how it works. I mean, I have a guess, but we don't know how it works. But if cells have a way of working out which transcripts, which genes are relevant, mutating those genes afterwards is trivial. CRISPR will do that. There's plenty of systems that'll mutate them. So the hard problem here isn't changing the genome. There are mechanisms to do that. The hard problem is knowing what do you change. But if cells have a way of working that out, we could, on purpose, engineer a system that would then go in, figure out which, and in fact, we're probably going to try that just as a synthetic biology exercise, like to figure out which genes are relevant and then go ahead and mutate them and see if, enrich for the good variants. So, it isn't magic and it's not any kind of, crazy creationism or anything like that, but it might mean that the intelligence of the medium, right? The problem-solving capacity of the medium that evolution is using. The evolution doesn't use a passive material. It's a material that can solve problems. That when you're using an agential material like that, your mutations, in fact, might not be random really with respect to what happens next. So that's kind of a tweak. It's a tweak. And so somebody's asking what my guess is. So for how it works. Okay, here's my guess. My guess is that the intelligence of that medium works roughly like this. I think it's an example of generalization. So I've never seen barium before, but I have seen epileptic seizures before. And in an epileptic seizure, we have excitotoxicity that kind of looks like what's happening when I can't use my potassium channels. So what I think this thing is doing is it's generalizing from this new particular to a category of problems that it does know how to deal with, which is absolutely a kind of intelligence. And I think that what it does then is it uses that kind of generalization to constrain the walk in that horrible 20,000 dimensional space to get closer to where it needs to go. I suspect it's generalizing. And there are some other examples. There are some amazing examples of generalization in biology that we could talk about. And I suspect this is it. Now, that's total conjecture. We haven't proven it. It leaves many open questions, but that's the only thing I can possibly think of for what's going on here.
Michael, if the planaria with the new head that is barium resistant, if they reproduce through normal means, so not by dissection, but through normal means, is the progeny also barium resistant? Do they pass on the trait?
Yeah, great question. So the species that we use for all this, they don't do much sexual reproduction. When they reproduce, they tear themselves in half and regenerate. So it kind of always is this regeneration. But I will also tell you that they lose the barium resistance in about 30 days. If you put them from that into normal water, within 30 days, they go back to normal and they become barium sensitive again. So they sort of forget about it over time, no matter what.
Is the change epigenetic, or can you do DNA sequencing and see a change?
We have not done the DNA sequencing. I don't think there are. Let's put it this way, you don't need DNA mutations for this because there's a million ways to upregulate whatever genes you want without changing the genome. And the same thing is true when we make our double-headed worms and things like that. But I haven't ruled out that they're, I just wouldn't claim that they're editing their DNA because I don't think you need that, but we haven't ruled it out by any means.
Fascinating.
Yeah, amazing. You're full of so many amazing stories and discoveries and conjectures, Michael, and just wanted to note that you've stayed about 10 minutes longer than you intended. I'd be very happy for you to stay for as long as you want. There won't be a deficit of questions.
I have to go in a couple minutes. If anybody's got a burning thing, I will. But I'm also happy to come back at some point.
That would be equally awesome.
Couldn't we bring him back still in this edition? In one of the next
we're here for
meetings?
the next 3 Sundays, and I can email you about that. And yeah,
thank you. That's very kind. Let's talk. I maybe if I can make it work, sure. I'm happy to. This is always fun. I'm happy to do it.
Yeah, you mentioned you had a couple of questions to bring as well. I don't know if we got through those or got to those.
We did not. I had some things for Bernardo that I wanted to talk about memory and reconstruction of memory. So we'll have to do that next time.
If you can make it back, we can start there. And as an incentive, we'll start with what you're most interested in. And yeah, so it looks like you're seeing the messages that come up in the chat. There's lots of enthusiasm and heart emojis for things that you've shared. And yeah, just deep gratitude for making the time and for everything you brought.
Thank you so much. I really appreciate it. And thank you to Yoromir, and thank you, Bernardo. It's always great to see you. Yeah, really appreciate the questions and your attention. Thank you so much. Yeah.
Thank you, Michael.
Likewise.
Yeah, appreciate it. Okay, I will see you all soon.
Take care.
Thank you. Bye.
Thank you.
Now that's a top guy, huh?
Yeah, amazing. Yeah.